Hi students, in this video we will talk about relative error and percentage error. So what are they? Relative error, look at this example. So there are two students, one is Amy, one is Harry. They try to estimate number of balls in a box. And the estimation are this. And the actual number, you can say that the first box is 38, second box is 102. So the absolute error, you can find it by finding the difference between estimated value and the actual number of balls. So they actually has the same absolute error. Okay, but which one is more accurate? Do you know that? So maybe we have to compare it by the absolute error with the actual value. So for Amy, she thinks that there are 40 balls and actually there are 38. Then the absolute error is large when it is compared to 38. But for Harry, the absolute error of 2 actually is small when it is compared with the actual value 102. So you can see that Harry's approximation is more accurate. Then we should try to measure the accuracy of the approximation, the degree of accuracy, when you use a term called relative error. And the relative error means the absolute error over the actual value. So this is the relative error. And remember that relative error would not have any unit. It is just a value. So look at this. Remember this example here. And the relative error for Amy's approximation, it would be 2 over 38. It is somehow approximately equal to 0.05 something. But for Harry, okay, his approximation, the relative error is 2 over 102. And that means it is approximately 0.019 something. So Harry's approximation is more accurate. But in measurement, if we want to measure something, we don't have the actual value. So what can we do? We don't have the actual value. Do we have the relative error? Yes, we still have the relative error, but we will use the measured value instead of the actual value. So the maximum absolute error rather than the absolute error, because for measured value we don't have the absolute error. So what does it mean? For measurement, the relative error will be the maximum absolute error over the measured value. Maybe we can try to look at some examples. Let's say there is a string and it is measured as 2 meter, and this measurement actually is correct to the nearest meter. Then what is the relative error? First, we'll find the maximum absolute error. It will be 1 meter over 2. That means 0.5 meter. And the measured value is 2 meter, so the relative error will be 0.5 over 2. That means 0.25, and we don't have units for relative error. Let's look at one follow-up question. Okay, the weight, you know that it is just a measurement, so we will use the maximum absolute error over the measured value. Part A, we found the maximum absolute error because the degree of accuracy is 0.1 kg. The maximum absolute error is 0.1 over 2. Divided by 2, it will be 0.05 kg. And for the relative error, it will be 0.05 kg. That means the maximum absolute error over the measured value. That means 67.6 kg. And we found the value 0.000740 because we want to correct it to 3 significant figures. So the relative error is like this. How about percentage error? What does it mean? Actually, this is a very simple concept. You just find out the relative error and then times 100%. Then we get the percentage error. Okay, so percentage error is the relative error times 100%. So actually, you don't need to memorize this you just know that what is relative error, and then times 100%, you can get the percentage error. So look at these follow-up questions. Okay, for these values, they are not measurement, so we can get the absolute error and also the relative error. The absolute error is the difference between the approximation and the actual value. That means this is 5. And the relative error is the absolute error over the actual value. So we get this. That means 0.005. And percentage error is the relative error times 100%. We get 0.5%. Next, this one absolute error is 0.3. Relative error 0.3 over the actual value. So that means 12.5. We get approximately this is 0.024, and the percentage error is this value times 100%. So it will be 2.4%. Okay? And this table is a measurement. So we get maximum absolute error, and then for this, because it's correct to one significant figure, that means it is correct to 1 cm, 10 cm, 10 cm, and then times 1 over 2, we get 5 cm is the maximum absolute error. And for the relative error, we can find it by dividing the maximum absolute error over the measured value, so 5 over 40. So it will be 0.125. And then the percentage error, change this relative error to percentage. That means 12.5%. For maximum absolute error for the next one, because it's correct to the nearest liter, so the maximum absolute error is 1 liter over 2. That means 0.5 liter. And the relative error is 0.5 over 200. We get 0.0025. And we change this value to percentage. That means it will be 0.25%. So these are the answers. So try your best on the quiz. See you next time.